Hi, and welcome to today's video where we are going to be looking at a different type of graph. We're going to be looking specifically at something called a scatter plot. And a scatter plot is something that when you are graphing, you are going to be comparing or looking for a relationship. And what that means is that we're looking to see if X is going to influence Y. That's the important thing to remember when we're dealing with scatter plots. So in this case, we've got some data here. We're looking at the weight of a car, and we're trying to compare and see whether or not that makes a difference in terms of its fuel economy. So in this case, we've got miles per gallon. So because we are looking at whether or not X influences Y, it's an important thing for us to know how to graph this. Where are we going to put weight, and where are we going to put the miles per gallon? And because we're looking at X influencing Y, or looking for a correlation or a relationship between these two things, we have to kind of think and use our brain a little bit. So if I look at MPG, if I look at miles per gallon, and I look at this and I say, okay, well, does miles per gallon affect the weight of the car? Well, that doesn't make a lot of sense because the miles per gallon is never going to change the weight of the car. If this all of a sudden was making 35 miles a gallon, it doesn't make the car any lighter. The weight of the car is going to be standard. It's going to be what it was at the time of production. So the weight will not change. However, if we look at it from the flip side, if we look at weight, will that influence the amount of miles that it gets per gallon? And in this case, we might assume that the heavier the car is, the less miles per gallon it's going to get. So that's going to tell us exactly where we're going to place our two different variables here. And the first thing that we're going to look at, of course, on the bottom, X influencing Y, is going to be weight. So we are going to put weight down here. Now, one of the things that we need to remember when we're plotting these graphs is that when we are going about and measuring out our graph, we want to make sure that we are using a range that is going to be indicative of all these numbers here. So we have to create ranges. What we do not want to do is this. We don't want to look and say, okay, well, 2200 is my lowest, and then 4700 is my highest, and then write 2200, 2300, 2700, or 2500 rather, then 2700. And why do we not want to do that? Well, if we do that, it kind of skews the way our graph looks. It means that this distance here would be 2200 to 2300, which is 100. And this one then would be, which is supposed to be the same size, 2300 to 2500. So we went plus 100 here, but plus 200 there. That doesn't make a lot of sense. So what we need to do then is we need to make sure that we are using ranges in which all of these spaces are going to be equal across. Now, let me explain that as I put some down. So what I'll do is I'll look for the lowest, and I'll look for 2200. So I'm going to start slightly below that. I'm going to start at 2000. And then I'm going to make my next one, I don't know, let's say we have to get all the way up to 4700, and I've got 1, 2, 3, 4, 5, 6, 7, I've got 8 dots, and maybe I can extend this a little bit more if I need to. So let's maybe go up by, I don't know, let's say 300s. So if I go 2300, then my next one should be 600, then 2900, then 3200, then 3500, 3800, 4100, then I'm looking at 4400, and then I'll have to extend this just a little bit more, and this will be 4700. Now, if you take a look, this distance is plus 300, this distance is plus 300, this distance is plus 300, and so on and so forth. So now I have a range that is equal all the way across. And we want to do the same thing for miles per gallon. I want to look at what my lowest number is. So in this case, we're looking at 17, and the highest number being 37. So it's probably fairly likely that if I went up by 2s, I should be able to fit all of these in. And on your graph, obviously, you're going to have guidelines. I just don't have them on the whiteboard here. So let's go 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, and 37. And then I'll go 39 up here just for fun. And now, again, I have plus 2, 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 so it is all equal. And now in terms of a scatter plot, what I simply want to do is I just want to compare the data now. So if I find 2200 on here, which would be about there, it's 33 miles a gallon. So I'm going to go up here to 33 and I'm going to put a dot. Then I'm going to go 4400 and I'm going to go to 19, which would be roughly about there, 26 and 32. So 32 would be there, 26 would be in the middle of 27 and 25. And all I'm doing is plotting these points the way that they're written. So 4700 would be 17. 2300 is here, and it's 37. 4100 is 22. 3700, which would be slightly about here. And you'll notice that I do not have to be right on this line. I'm trying to find somewhere in that range, approximate. 3700 is 28. 25 would be about here. 33. And then 3500 would be 28, which would be about there. Okay, now this is what a scatter plot looks like, and what we need to do now is we are trying to look for a pattern. And if you're looking at this, you might say, well, gee, I kind of see a pattern. As the weight is increasing, the fuel economy is going down. So what we want to do then is we want to create a trend line. And a trend line kind of gives us an idea about which way our pattern is working here. We can see that it's obviously going down. There we go. And now we've created this trend line, and there are 5 different types of trends that you can look at when you are looking at a scatter plot. When the dots are close to the trend line, which is what we've done here, and you'll notice that I'm cutting through some of these dots and some of them are kind of floating on below and above. We want to try and place our trend line in the middle. So if I was to count 1, 2, 3, there are 3 on the top, 1, 2, 3 on the bottom. I'm pretty in the middle, I think. There's 3 on the top, 3 on the bottom. Now this trend line, as dots are close together, we call that a strong correlation. And simply what we're doing is which direction is the line going will determine the other part of the correlation. Looking at this, we can see that there is a somewhat strong correlation, but it's going down. So we are going to call that a strong negative correlation, which means that, yes, it does look like there is a relationship between the weight of the vehicle and the fuel economy. Now I mentioned that there were 5 different types of correlations that we're going to be looking at in class. We are going to be looking at strong positive, which is going to be a line going up on the graph with dots nice and close together to the trend line. We are going to be looking at weak positive, which are going to be still an upward progression, but the dots are going to be not as close to the trend line as a strong would be. We are going to be looking at a strong negative, which you can see here, and we are looking at a weak negative, which is going to be the opposite of a strong positive, where the dots are still going down in a downward direction, but they're not super close to the trend line. And then finally, we're looking at no correlation, and no correlation means when the dots are kind of scattered all over the place and we really don't see any type of pattern. So just quickly to recap, what we are looking at here is we are looking at comparing x to y. Does x influence y, or is there a relationship between x and y? And then we're making ranges that are all equal on both the x-axis and the y-axis, simply plotting the data using dots, looking for a pattern, creating a trend line, and then deciding whether or not we have strong, weak, or no correlation. This is scatter plots. If you feel like you need to rewatch the video, please do so. If you have any questions, please comment below. Don't forget to share this video, and thank you very much for watching.